Hey guys, it's Jensen. It's about 11:30 right now. I just really want to go sleep. I just came home, so this is the short spring, and we're given the short spring, which is the harder string, because it's short. So if it's shorter, it has more force or more energy stored inside because it's harder to push or put force against or put energy against, so that it can spring up. So going to the graph. Here's my graph. And we're given that my equation is for the equation is 5.19 newtons over meters delta x, or change of x, minus 0.3037 newtons. Now this one is basically the force when spring is on stretch, basically the force inside the spring, like as Hooke's law. In Hooke's law, we're given that this this one is the energy. Well, I want to get back to that later. This is the long spring force. This is the long one, but has a smaller amount of energy. Because if you compare here with my F spring, here's my equation: 3.460 newtons per meters, and delta x with 0.2018 newtons. Well, this one is negative 0.3037 newtons. Where this one is for every 1 meter, the spring exerts a force of 5.198 newtons. While this one is 3.460 newtons over meters, but for every 1 meter, the spring exerts a force of 3.460 newtons. And here's the force spring when it's unstretched. So as you can see, it's a little bit smaller than the short spring. And so let's go back to this, which is basically the Hooke's law. Hooke's law this equation here is our spring. Basically, this one we have to put that here. So for example, we're given this equation. So we're given this that for every 1 meter, this with stretches like 3 newtons, or the force is 3 newtons. And here, this one is like the landing force, or when delta x is 0, when there's no change, or when the spring is unstored. So if we put this there, which is Hooke's law, K is basically K is the force on the string of the object. So that's the force on the string of the object. So if we actually just put this in K with delta x, we're given here, for example, see that K times delta x times delta x. Put this equation in this equation, which is F spring. That is the equation for this. We're given that 1/2 times K times delta x squared. So same thing as Robert Hooke's. And for Joule, Joule made this equation to find the energy. Like, we're finding the unit of measuring energy, newtons times meters. So we're given this again. So again, E times EL equals 1/2 force of spring times delta x. Well, this one is energy of elastic equals 1/2 times K delta x, which is the force of the force spring. The force spring. Oops, that's not it. This one basically, and the delta x, which is a while ago, and we're given this equation. See you guys.